Hi everyone. Welcome to the class, guys. Hi, good evening, Itanago. Guys, please confirm once that am I audible to you or not? Shillong, Itanago, guys, confirm once. Can you hear me clearly? Am I audible to you? Okay, Itanago. Hi, good evening, Shillong. First of all, tell me, guys, how are you? How's everything going on? All good? Hi, guys. Okay. Okay. So guys, any question for me? Any question which is related to the previous topic that we have discussed? Anything that you want to ask me? If not, then please confirm so that we can proceed. Okay. So no questions so far. So guys, let's continue with the covalent character that we were discussing in the previous class. Okay. I have discussed that covalent character is directly proportional to the charge on the ions, whether it is cation or the anion. Okay. Higher is the charge, more will be the polarization, which is distortion, and higher is distortion, greater will be the covalent character in the compound. Okay. So based on that, I'm giving you a question, guys. Solve that question. Arrange the following. In the order of increasing covalent character. Attempt this question. This question is based on the last point that we were discussing in the last class. Okay? And tell me what will be the answer for this one. Okay, Tanago. What about you, Shillong? What's your answer? Okay. So guys, look at this. Here aluminium is common in all of the compounds, so aluminium won't be the decisive factor. So we have to check on the basis of the anion. Here, the charge on anion would be -3, it is -1 and it is -2. Okay. So higher is the charge, greater will be the distortion, okay, and higher will be the covalent character. So we can say that AlF3, then Al2O3, and then Aln. This one will be your answer. Copy. Okay, now guys, you can make a note that polarization is directly proportional to charge on anion, is directly proportional to covalent nature, is inversely proportional to the melting point. Copy. Copy this one. And based on this, do practice this question. Which one will have higher melting point? MPT stands for the melting point. Question is CaSO4 and Ca3PO4 whole twice. Attempt this question. Tell me the answer. Tell me your answer. Tell me the answer. What you can do, you can simply determine the covalent character and just reverse that to find out the melting point. Shillong, Itanagar, guys, are you there? Have you done this question? How many days will you take to do this question? In CSO4 and PO4 hold twice, there is a difference between SO4 2 minus and the PO4 3 minus. This one has got -2 charge. This one has got -3 charge. So obviously, Ce3PO4 hold twice would have the higher covalent character. Means for the melting point, CaSO4 should have high melting point. CaSO4 would be higher than. Okay, this is the answer for this one. Next, electronic configuration of cation. Look at this. You have to remember one thing, that pseudo noble gas configuration should have higher covalent character than noble gas configuration. Now question is, what is a pseudo noble gas configuration? If outermost electrons contains NS2, P6, D10 electrons, then it is called the pseudo noble gas configuration. And this is nothing else but what? NS2, NP6. Sorry. Let's take an example. Let's say suppose we have got CuCl and NaCl, and we need to determine that which has the higher covalent character. So this is your Cu plus, this is your Na plus. If you check out the electronic configuration, you will find out that the outermost configuration of copper is 4s2, 3d10, it is 3p6 then 3d10. Okay, whereas sodium is what? It is 10, so it is ultimately 2s2, 2p6. Okay, so you can check out here, the outermost configuration contains the 4s2, 3p6, 3d10. This is 2s2, 2p6. So this is actually the noble gas configuration, whereas this one has got the pseudo noble gas configuration. Means outermost shell are containing what? 18 electrons. Not exactly all outermost. Okay. And this contains what? 8 electrons. Okay. So you can simply check out this one and copy this one. Got it, guys? If anyone having any doubt, you can please ask me. If anyone is having any doubt, you can please ask me. See, your camera in the Shillong center is not working, as in net speed is very slow, so I cannot see your actions, so you need to use the chat screen, Shillong. And Itanagar, you as well. Okay, please copy this one. Done? Shillong, have you done that? Let's move on. molecular orbital theory. You will definitely get a question from this theory. See, there were some points which cannot be explained even by the valence bond theory as well. Okay, like O2 having the even number of electrons, but still its behavior is paramagnetic. Okay, what is the meaning of paramagnetic? We'll discuss about it later on. Okay, so the point is, some of the points have not been still explained clearly that why is this happening here. Okay, so to explain those points, a new theory has been introduced by the Pauling. Okay, and this explains all the reasons that has not been discovered at that time. Okay, so this is the molecular orbital theory. Okay, that we have to discuss. It depends on certain postulates that this should be happen. Okay, means this is the cause of this one. Okay, and later on that comes to be true as well. Okay. First of all, make sure that understand the meaning that molecular orbital theory, that this theory is applicable to molecules only, not for the atoms. Okay, this is applicable to molecules only. Depends on certain assumptions or certain postulates over there. Okay, but yes, it has a very, we can say the very importance actually to explain certain points. Okay, so first of all, let's write few of its points. That the atomic, means this is the definition of this theory, that the atomic orbital lose their identity. Guys, please, when I'm writing, just copy this one along with me. Okay, I'll discuss each and every point in detail. Okay, so don't worry for that. The atomic orbital lose their identity during molecule formation, which is overlapping, nothing else. And form new orbitals. Termed as molecular orbital. It's simply saying whenever a molecule is formed by the atoms, okay, so atoms totally lose their identity, means what was their nature initially, okay, what is the behavior of those atoms initially, okay, what were the properties, whatever properties do they have, okay, means they could have the weaker bonds, they can have the lower nuclear forces over there. But once the molecule is formed, the properties of the molecule will be different from the atoms by which it is combining. Okay, molecule will become the more stable as I compare with the single atom. Let's take an example that a single hydrogen atom cannot exist, but yes, hydrogen molecule exists. Okay. So hydrogen atom and H2 molecule is totally having the different identities. Both are having the different identities over there. Same thing with the oxygen molecule, fluorine molecules, chlorine molecule. Okay. So this is the basic of this theory. Whenever the atoms will combine, they will form the new molecules, and the new molecules will have a new identity. They will be different from the atoms. Okay. In terms of the features actually. Whether it is stability, their behavior, okay, their existence, okay, many points are there. Now, let's move on. Let's start with the characteristics. First, molecular orbital formed by overlapping of atomic orbitals of same energy. Next, number of molecular orbital formed are equal to number of atomic orbital involved in overlapping. Half of the molecular orbital have lower energy are called bonding molecular orbital. Half of the molecular orbital have higher energy are called anti-bonding molecular orbital. Copy first, then we'll move on to the next point. Copy and then confirm. Okay. Electronic configuration. In various molecular orbital are governed by same three rules. Of Bose rule, Hund's rule, Pauli's exclusion principle. Okay, copy this. Guys, everyone please copy and confirm. And after that, we'll discuss about the difference between the bonding and the anti-bonding. Now, the first question is, how do they form? We'll discuss about that one as well. Let me explain these points to you. Just confirm after copying that. Everyone. Shillong, have you done that? Okay, let's start. We have discussed the point number 1. Let's discuss about the point number. Oh no, I guess so. We haven't discussed the point number 1 as well. Yes, it is saying that molecular orbitals are formed by the overlapping of atomic orbitals of the same energy. Yes. Let's suppose if we talk about the hydrogen molecule, two hydrogen atoms are overlapping with each other. Obviously, both the hydrogen should have the same energy. Okay. So it is saying that the atoms having the same energy would overlap with each other. Okay. Remember one thing, guys. They are saying the same energy, not the same atom. Okay. Whenever there is a chances that the different atoms could have the same energy, they might also overlap. Okay. The condition is energy should be the same, not the atom. Next. Number of molecular orbital formed are equal to number of atomic orbital involved in the overlapping. Yes, definitely. If two atomic orbitals are overlapping with each other, then we will get the two type of molecular orbital. Okay. If four atomic orbitals are overlapping, then we'll get the four molecular orbital. If six atomic orbital are overlapping, then we'll get what? 6 molecular orbital. Okay. But yes, the one condition is the half of, exactly half of atomic orbital. See, if you are saying the two atomic orbital which are overlapping, so half of 2 is what? 1. So it is saying that the 1 will form the bonding molecular orbital and 1 will form what? Anti-bonding. Means half of the molecular orbital have the lower energy, means higher stability, are known as what? Bonding molecular orbital. Half of the molecular orbital have the higher energy, means lower stability, are called as what? Anti-bonding molecular orbital. Okay. Other than that, how we can fill up the electrons, I guess so we have already discussed about it in the structure of atom, but here we will also discuss it again. Okay. For the molecules, in the structure of atom we have discussed these 3 rules for the atoms. Here we will discuss about the molecules. It is simply saying that electronic configuration in the various molecular orbital are governed by the 3 rules, which is Opper's principle, Hund's rule, and the Pauli's exclusion principle. Okay. So these are the 5 points. I hope so it is clear to everyone. If not clear, you can please ask your question. And if yes, then let's proceed. Okay. Now actually, what they say, they consider the atoms are nothing but the wave functions. I'm considering the case where 2 atoms are overlapping with each other. They consider that atoms are nothing but what? Wave function. Means they are waves. Okay. And mathematically, that can be represented like this, that the wave function of atom A is represented by the psi A. This is the psi. Whereas wave function of atom B can be represented by the psi B. Check out this one. They are simply saying that the atoms are nothing but the waves. Okay. So we won't consider them as a simple sphere. We have to consider them as a wave. Okay. And when two waves are there, so there are two types of overlapping possible over there. How? Check out this one. Let's say suppose these are the waves. Okay. Okay. Now check out one thing, guys. The positive phase is overlapping with the positive phase. Means both the waves are exactly having the same phases. Means both are the mirror images, we can say. Okay. So this is, let's suppose psi A, and this is what? Psi B. Okay. So obviously when they will overlap with each other, the net magnitude, net magnitude as in means the amplitude of the wave, not the magnitude, yes, amplitude of the wave will increase. So the resulting wave will look like this. Getting this? This is known as what? Constructive interference. Okay. And this is the psi A plus psi B. Means two waves are just getting each other, or means just getting adding with each other. Okay. There is another possibility. Let's say suppose two waves are representing like this. See, the phases are different, guys. This is psi A and this is what? Psi B. If phases are different and different, if you are still adding them, means what will happen? The amplitude will decrease now. Okay. And might be possible that you won't get any amplitude over there. Okay. But I'm saying it is just a possibility. It doesn't happen over there. Okay. So the resulting wave now will look like this. Okay. This results into psi A minus psi B. Okay. This is known as what? Destructive interference. Destructive means it destroys the amplitude of the current wave. Okay. Just because they are having the different phases over there. Okay. So actually what we have to conclude, that psi A plus psi B is the bonding molecular orbital. This is known as bonding molecular orbital. Means this forms the bonding molecular orbital. And if you use the psi A minus psi B, this is anti-bonding molecular orbital. Anti-bonding molecular orbital. Okay. So guys, this is the concept that how you can get the bonding molecular orbital and the anti-bonding molecular orbital. So first of all, copy this one. Everyone please copy and then confirm. And if anyone having any doubt, please ask me. Guys, anyone having any doubt? Copy. This one as well. This one as well. Copy and then confirm. Okay, so let's move on. Now, comparison. Guys, please don't feel shy. If you are having any doubt, please you can ask me your doubts. Okay, if anything it's not which is not clear to you. Comparison between bonding molecular orbital and anti-bonding molecular orbital. So this is bonding. This is your anti-bonding. First, it is formed by linear combination of atomic orbital when wave function are added. It is formed by linear combination of atomic orbital when wave function are subtracted. You can simply say this is psi A plus psi B. Generally, it does not have nodal plane. I hope so you know what nodal plane is. It always have a nodal plane. Between two nuclei of bonded atom. Electron density increases between two nuclei resulting attraction between two atoms. Electron density decreases in between two nuclei, leads repulsion between two atoms. Energy of bonding molecular orbital is less, hence stable. Energy of anti-bonding molecular orbital is high, hence less stable. Electron placed in a bonding molecular orbital stabilizes a molecule. Electron placed in anti-bonding molecular orbital destabilizes the molecule. Okay, guys, first of all, copy these points. And here's one more thing. Notation. It is sigma pi. Means these are the bonds. And it is sigma star, pi star. Copy and then confirm, guys. Copy and then confirm. Okay, so let's find out some important terms here. First point, I think it has already been discussed, that it is formed by the linear combination of atomic orbitals when wave functions are added, and here wave functions are subtracted. Okay, then generally it does not have the nodal plane. Does not have. A nodal plane means a plane where we won't get any electron. Okay, so it is saying that here we will definitely get electron. There is no nodal plane over there. And about the nodal plane we have already discussed in the structure of atom. Okay, a nodal plane is the is the plane where the probability of finding the electron is 0. That is called the nodal plane. Okay. Now, if we talk about the point number 3, electron density increases between the two nuclei, resulting into the attraction of the two atoms. Means attraction between the two atoms. Means that we know that whenever there is a higher attraction, it means that higher stability. Okay. So with the increase in the electron density, attraction also increases over there, and it stabilizes the molecule. Okay. And here it just reverses happen, that electron density decreases, which leads to the repulsion between the two atoms. Means that now two atoms are repelling each other. So they are already repelling each other. It means that they do not want to be in contact with each other. Okay. So that leads to the instability. Okay. We know that the molecule, or we can say the element which is highly stable or higher stable, are having the lower energy. So energy of the bonding is less, hence more stable. Whereas here the energy is high, it means it is less stable. Okay. Now, this point is very much important. This point is very much important. When we talk about the stability of the molecules. Okay. That electron placed in a bonding molecular orbital stabilizes the molecule. Whereas if we place the electron in anti-bonding molecular orbital, it will destabilize the molecule. Okay. So these are the 5 points that we have to discuss, and notations are simple: sigma and the pi bonds. Bonding will be without star, and anti-bonding will be with the star. Okay. So please confirm me one thing, that is there any doubt or any point of confusion that you want to ask me, or you want me to repeat any point? Please just confirm me once. After that, I'll start with the notations, or we can say the how these bonds are formed. Just confirm everyone. Eternal question long. Okay. Okay, so let's start. Now the topic is shapes of molecular orbital. Okay. First is sigma molecular orbital. Okay, how sigma is formed? Let's say suppose two 1s orbitals are overlapping with each other. We know that how sigma is formed. Okay. So let's consider that there are two 1s orbital. One, and this is another one. Okay. This is the bonded region. This is your nucleus. Okay. So when these two 1s orbital are overlapped with each other, there are two possibilities of the overlapping. Means when we consider their wave functions, we can have the two possibilities. First is addition, and second is subtraction. Okay. When addition takes place, then your new molecular orbital will look like this. See, there are two positive charge, means two nucleuses. Okay. So this is your sigma 1s. Okay. When subtraction is there, I'll draw a dotted line. This dotted line represents the Reason where you won't get any electron means is the nodal plane. Okay, and this one will look like this. One second. Okay, this is your nodal plane. Guys, these geometry look like this, so you have to learn them as it is. Okay, but yes, you can say this is what sigma star 1s. Okay, this one is your bonding, and this is your anti-bonding. See, one line means one nodal plane over there. Okay, just copy this one. Copied. Copied, guys. Shillong, Itanagar. Okay. Now let's check out the PP overlapping. See? Two p orbitals. Okay. Again, two possibilities are there. Addition, subtraction. Now, look at this. Positive, negative, negative. This is sigma px. And here, it will look like this. This is your sigma star px, anti-bonding. And this is your bonding molecular orbital. Okay. Again, you can check out there is one nodal plane. One nodal plane. Copy and then confirm, guys. Guys, this is the second last topic of this chapter. Okay. In the next class, we'll wind up this chapter completely, as well as we will start with the states of matter as well, which is the next chapter. and next chapter contains lots of numericals. Okay. Okay. Shillong, have you done that? Shillong, have you done that? See, I guess someone is trying to tell me in front of camera, but dear, net speed is very slow, so your actions are not clearly visible actually. I have just spotted someone's hand that was in air. Okay, so please use the chat screen. Okay, let's start. And yes, guys, please confirm one thing to me. When your final examinations are going to be happen, please tell me the month. Okay, I guess so. Or nobody has the dates of the final examinations or upcoming examinations as well. Okay, please tell me your dates of the upcoming examinations, whether it is in December or January. And what about the final examinations? You are saying the Fab is the final examinations, a turn ago. Shillong, what about you? Will be in the Fab. About first week, second week, third week, fourth week. When in Fab? Give me the rough idea. First week. Okay. Sorry. Fine. Okay, guys. So again, in this overlapping, there are two possibilities. Subtraction, addition. Can anyone please tell me, by looking at the diagram that I have just drawn for the subtraction case, how many nodal planes you can observe over there? Can anyone please tell me how many nodal planes you can observe? Okay, very good. And in the current diagram? In the current diagram? Yes, very good. See, I have told you that the dotted lines are representing the nodal plane. So you were absolutely right. This one and this one are nodal plane. So this one has the two nodal planes. And the interesting part here, even bonding contains one nodal plane. Okay? Please copy and then confirm. So this is the writing section that we have completed. And now we'll move on to the question section, means how we'll get the questions based on this one. Okay. Means this one is the core concept of molecular orbital theory. Now let's move on to the question part. Copy and then confirm. Shillong, have you done that? Okay, good. Now guys, you have to do one thing. You have to learn this. Electronic configuration. There will be only two cases. First, when electrons are 14 or less. The configuration is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, then pi 2px, pi 2p, y, sigma 2p, z, pi star 2px, pi star 2py, sigma star 2pz. Case 2. When electrons are more than 14. Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2pz, pi 2px, pi 2py, pi star 2px, pi star 2py, sigma star 2pz. Copy please. And just confirm. Then I'll tell you that how you can memorize it. Copied Shillong. Show the centers connected, please. Hey Satna, what happened? Are you there? Am I audible to you, Satna? Is your chat system working, Satna? Okay. Please confirm once, Satna. This is for you. Okay, so guys, what you have to do, you have to learn one of them. I'll suggest learn first one. That sigma, one second. sigma 1s, then sigma star 1s, sigma 2s, sigma star 2s. Pi 2px, pi 2py, sigma 2pz. Then pi star 2px, pi star 2py, sigma star 2pz. Then to write the second one, what you have to do? Just place this one here. And you can check out, rest was exactly same. See, sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Then sigma 2pz, look at this. This has been placed here. And rest was exactly same. Pi 2px, pi 2py, pi star 2px, pi star 2py, sigma star 2pz. Okay? So this is how you can simply learn it. Okay? And yes, guys, one of the most important thing, that each and every notation, or we can say these are representing the orbitals. Like this is a single orbital, can accommodate maximum of 2 electrons. Again, this is a single orbital, which can accommodate maximum of 2 electrons. This is single, even this one is a single orbital. See, it is 2px. Look at this. Just to confirm it, look at this. We know that the p subshell can contain the 6 electron. So this is px, this is py, this is pz. If I ask you, how many electrons can px accommodate? Means this orbital. What will you say? 2 electrons. How many py can accommodate? 2 electrons. How many can pz accommodate? 2 electrons. Are you getting this? So after adding all this, you will get what? 6 electrons. Okay? So do remember one thing, guys. This is not p subshell. This is the p orbital. So maximum you can write only the 2 electrons. Okay? Not more than that. Okay? They all are the individual orbitals. Okay? P is not subshell here. This represents one subshell. Look at this. X, Y, Z. Now this is representing the subshell. Okay? But individually these are the 3 orbitals. Getting it? Now, bond order. Bond order simply means how many bonds can be formed. So it has a formula that bond order is equals to what? Half of number of bonding electrons minus number of antibonding electrons. This is the formula. N base number of electron present in bonding molecular orbital. Na number of electron present in antibonding molecular orbital. Okay. Next thing, bond order is directly proportional to the stability. Okay. Inversely proportional to the bond length. Copy, please. Copy and then confirm. Copied, Shillong. Okay. Now, paramagnetic. Means magnetic behavior. Can be of 2 types. First is paramagnetic. It is due to presence of unpaired electron. Okay. Number 2, diamagnetic. It is due to absence of unpaired electron. That is, all electron present in orbitals are paired. Please copy. Done? Okay. Look at this. One more important note. If bonding electrons are greater than anti-bonding electrons, molecule will exist. If bonding electrons are equal to anti-bonding or bonding are less than anti-bonding, molecule do not exist. Okay? We have to practice few questions based on this one. Okay? Just copy, open up your mind, just relax and look at the screen after that. Because I'll teach you 2 questions and you will answer me 10 questions. I think fair enough. Itanagar, Shillong, Satna. Can we start, guys? Okay, let's start. Question is, determine bond order, magnetic behavior, and compare stability of the following. N2, N2 plus, N2 minus, O2, O2 2 minus, and O2 minus. Okay? In the exam, you can get any one of these molecules. So I'm starting. Just look at the screen. Do not copy anything. Relax. Just observe what I'm doing. First of all, let's talk about the N2. Can anyone please confirm how many electrons will N2 contain? How many total electrons will N2 have? Electrons in N2. I think very serious question this is, no? Very difficult one. But you have to tell me the answer. Only after then I'll start. Okay, get it. 14. Very good. Okay. So 14 means it is a case number 1. So just write the electronic configuration, which is sigma 1s. I have told you it is the orbital, so it can have 2 electrons. See the power representing the electron. Then sigma star will come in. Then it is 2. Then sigma 1s. Then sigma 2s. Sigma star 2s. Okay. Then pi will come. Pi 2p x equals to what? Pi 2p y. This can have 2. This can also have the 2. Just count how many electrons we have filled till now. It is 2, 4, 6, 8, 10, 12. Okay, let's fill the rest. Sigma 2p z. Okay, we are left with only 2. I guess so we filled up all the 14 electrons. Okay. Now calculate the bond order. It is half of bonding minus anti-bonding. Check out the bonding electrons. Means pick those orbitals which are without the stars. Without the stars, so let me use this one. Yeah, I'll use this one. Without the star, 2, 4, 6, 8, 10. Okay, so this is 10. And with the star, you can find out there are only 4 electrons. So 10 minus 4. It is nothing but half into 6, which is 3. I hope so everybody knows that N2 can have the maximum of 3 bonds. I mean, N2 makes the 3 bonds over there. Do you remember? The N2 actually, this molecule which has the 3 bonds. Okay. Now, can you please confirm me, in the whole electronic configuration, have you ever find any unpaired electrons? Means, can you see any orbital which have 1 electron? 1 electron in the whole configuration. Check out the configuration, means on the screen, and tell me, have you find any orbital which has the 1 electron? I guess so you have to supposed to say yes or no. Okay, yeah, no, very good. Yes, there is no such orbital exists which has the single electron. So bond order is 3 and magnetic behavior is diamagnetic. Okay, so actually we have to compare the stabilities, but before comparing the stabilities, we need to determine the bond order of every molecule. So just confirm me, are you clear with the N2? Confirm me once, are you clear with the N2? Guys, say something, yes, no, yo, go, anything. I mean, don't say go, you can say yo. Wow. Blank message. Shailong, will you say something? Just copy, guys, copy the first question. I mean, answer of the first question. After that, I'll discuss one more question with you. Then you will solve rest of the questions. Shilong, are you clear with this one, or you are having some doubt? If you are having some doubt, please ask me. And Itanagar, Satna, please copy and then confirm. And Shilong as well. Copy and then confirm, guys. What about you, Shillong? Okay, guys, so let's move on to the next question. Oh, Shillong, wow, you're there? I thought you have gone. Okay, guys, so I'm discussing O2 with you. As we can see, O2 can have the 16 electrons, so let's fill these 16 electrons, and this should follow the case number 2, which is more than 14. So this is sigma 1s2. Guys, very important question. Even you will find the same question in class 12th as well. Okay. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2p2z, pi 2p2x equals to pi 2. This equals to represents that these two are having the exactly same energy. Oh, hi Satna. This is why. How many we have filled till now? Let's check. 2, 4, 6, 8, 10. Oh, then 12, I guess 14, and 2 are left. 1 second, 2 are left. Pi 2px with a star and pi 2py. Now guys, the problem is we need to fill the 2 electrons, okay? I hope so you remember one thing, that if I need to fill the 4 electrons in these 3 orbitals, how we fill this? 1, 2, 3, 4. Means first of all we make all of them half filled and then we start the pairing. Same thing we have to do here. 1, 2. Okay? Are you getting this, guys? This is how we will fill the electrons here. Okay? And now, I guess so 16s are filled right now. So let's calculate the bond order. Half of bonding minus anti-bonding. So let's check out the bonding first. 2, 4, 6, 8, 10. 10 are bonding. 6 will be in the anti-bonding. So this is half into 4, which is 2. Now please confirm me one thing. In the whole configuration, can you see any orbital which is having the unpaired electron? Can you see any orbital which is having the unpaired electron? Means which contains the 1 electron. Okay, yes. Just because of these 2. See, we need at least one. But here we have got the 2. Okay. So its magnetic behavior will be what? Paramagnetic. Okay. I hope so it is clear to everyone. In the exam, even you get the question, why O2 is paramagnetic in nature? So you will simply say, O2 is paramagnetic in nature due to presence of unpaired electron in antibonding pi orbital. Okay. Even you have to mention this. Okay. Oh, 1 second. Yes, this is. Even you have to mention this. O2 is, means this behavior of O2 is not explained by the VBT. That's why we have to use the molecular orbital theory. O2 is paramagnetic in nature due to presence of unpaired electron in antibonding pi orbital. Please copy and then confirm. Copy and then confirm. Satna, Shillong, Itanagar. Satna, where were you? Why are you not responding on the chat screen? Done? Okay, those who has completed this, now this is your turn. What was the rest questions? N2 plus N2 minus. Okay. Now it's your turn, guys. N2 plus means 14 minus 1, 13 electrons. Tell me bond order, magnetic behavior for N2 plus. Quickly. Guys, you have to tell me the answer. Shillong, Satna, Itanagar, guys, have you done that? You have to tell me the bond order and the magnetic behavior. Who has got this answer? Please write your name as well. Okay, very good. Please you write your name as well. What about you, Itanagar and Satna, guys? What's your answer? Okay, Itanagar has given the answer. Okay, let's check out. It is sigma 1s, sigma star 1s, sorry, 1s2, sigma 2s2, sigma star 2s2, then pi 2p2x, pi 2p2 y, and then this is how much electrons? 4, 8, 1 second, 8 to 12, yes, then sigma 2p 1 z. Okay, so let's calculate the bond order. Half of bonding is 2, 4, then 8, 1, 9, minus 4, which is 2.5. And just because of this one, this is paramagnetic. Okay, so congratulations to Mandy, Rida, Lehnam, and then Sweetie. What about you, Eliza? Have you solved the question? And Itanagar, please correct it. And guys, the rest of the molecules are the homework to you. Okay, you have to determine the bond order of each and every molecule which I have given to in the homework. Okay, and after that we will arrange them in the order of increasing stability. Okay, so that's all about for today's session, guys. Thank you so much. Okay, I'll see you next time. Till then, take care. Bye bye. Good night.